In our previous lecture, we have discussed the concept of sets in detail. Today we are going to see what are the different types of sets. As we came across different types of sets, and we are unable to decide being how they are being classified. So let's see how many types of sets are there. Okay, there are three categories in which the sets are being divided. We will discuss them one by one. First category is the types of sets based on number of elements. Okay. Second category is the types of sets based on equality. We will discuss them one by one in detail. And the type of sets based on membership. Okay. Now let's see what are these different types. Okay. Based on the number of elements, it is divided into four types. One is the finite set, another is infinite set, then singleton set, and the other is the empty set. These are the types of sets based on the number of elements in the set. Now we will see what are the different types of sets based on equality. Okay, one is the equal sets, and another is equivalent set. How they are different from each other, we will see shortly after a while. Equivalent sets and the types of sets based on membership are subset, another is superset, then proper subset. It is a type of subset, but they all came under this heading. And the other is improper subset. Okay, these are all the types of sets based on different properties. Let's discuss them one by one so that you can easily distinguish between them. We'll start from the types of sets based on the number of elements. Types based on number of elements. For that we will make a table so that you can memorize it easily. Okay, let's make a table for that so that you can easily memorize it. Okay, we will have as we have four types of set, so we will have 4 rows and 3 columns. I'll try to cover it up as quickly as possible. Okay, so we will write here the properties. Okay, 1, 2, 3 and 4. So we'll write one by one here. Okay, first we will write the types here. Okay, number of elements here, as we are categorizing them on this basis. Okay, and here the example so that they may be differentiated easily. Okay, first type of set here is finite set. As its name indicates, finite means uh, anything that has some limit, that is that or the anything that can that about which you can tell that what is its end. Like for example, first we see how many number of elements are in a finite set. We will say in a finite set we are having a limited number of elements. Okay, limited number of elements means that have some limit, that is not infinite or that is not unknown that where it will go on. Let's take an example. Example is A is equals to set of natural number less than 10, less than 10. Set of natural numbers less than 10, it means it is limited. This set is limited to 10, to the number of elements up to 10. We cannot go beyond that. Okay, another example is set of vowels in English. Set of vowels in English. How many number of elements in vowels? A, E, I, O, U. 5 number of elements. It means it is also having a limited number of elements, and both of these sets are finite sets. Now, the next type is infinite set. Infinite set. As its name indicates, it has unlimited number of elements. Unlimited number of elements. Okay, now what are the examples? Let's see what are the sets that have unlimited number of elements. A is equals to set of odd numbers. Set of odd numbers. Odd numbers are 1, 3, 5, 7, 9, 11 and up to so on. There are unlimited number of odd numbers in mathematics. Okay, another example is set of whole numbers. Set of whole numbers. This set also consists of unlimited numbers. Start from 0 and up to so on. We cannot say that the whole numbers are up to 10 or 11 or 12 or 100 or 1000. We don't have the limit of this set. So this is called infinite set. Any set that have no limit, it will be called as infinite set. Then the next type of set based on the number of elements is empty set. Empty or null set. We can call it in the both ways as empty set or a null set. Now what will be the number of elements in the null set? Just guess. Okay, so it is clear from its name. Empty means nothing, 0. Okay, empty means nothing, 0, and the null is also reflecting the same thing. It means the number of elements is 0. Number of elements. 0 number of elements. Now let's see what are those sets that have 0 number of elements. A little bit odd thing, that how is this possible that any set has a 0 number of elements. Let's find out. First of all, we will see its notation is an important point to be noted here. Is notation is this. We don't write it in the form of a set. We just write this sign. This is called phi when we represent an empty set. Okay, and other than that, we are having the example of an empty set is set of 100 feet tall boys. Okay. Now, is it possible to have a set of 100 feet tall boys? No, there no one in the world that is having a height of 100 feet. So, what will be the result? Result will be 5. We will represent this set by a is equals to 5. Okay. Another example is set of days of 24 hours. Set of days of 20 25 hours, sorry, 25 hours. So is there any a day that consists of 25 hours? No. So this will give you a set with the answer of empty set, a null set, a set that have no element, have zero number of elements. Okay, the last type of this category is singleton set. Singleton set, as its name indicates, single means one unit. So how many number of elements? There will be one number of element, only one element. Okay, any set that is having only one element is called singleton set. What are the examples? Example is A is equals to A. This is a singleton set. B is equals to B. This is a singleton set. So these are the examples of the, first of all, the types, then the number of elements, and with examples that how you represent them. So this was the type of the sets based on the number of elements. Now let's see the types of the sets on the basis of equivalency. Okay. Types of sets based on equivalency. Okay, let's see what are those types. Based on equivalency, there are two types of sets: equal sets and equivalent sets. Okay, let's discuss them one by one. Equal sets and equivalent sets. Okay, now we'll describe them one by one with example, so that you may not have any kind of ambiguity regarding their concepts, that how they differ from each other. Okay, so we are having the types of sets. First of all, we will see what are equal sets. We will define it in a way, if each element of set A is also an element of set B, then the sets are called equal. Then sets are equal. Let's take an example so that you understand it. Okay, example is A is equals to 1, 2, 3, and B is equals to 3, 2, and 1. Now, are these sets are equal? Yes, they are equal, as the number of elements are same. Okay, and the elements itself are the same. Okay, here we are not only concerned with the number, we are also concerned with the elements itself. Like in set A there is a 1. Okay, In B it is also 1 is there. We will see 2 is in A. We will check in B. Yes, 2 is in B. Then 3 is in B. Yes, in both A and B 3 is present. It means that the elements as well as the number must be equal for the sets to be equal. Okay, so this was the equal sets. Now let's see what are the equivalent sets. Equivalent sets are stated as two sets are equivalent only if and only if 1 to 1 correspondence exists. Okay, now what is 1 to 1 correspondence? Let's see from the example, as examples are the best way to understand any concept. A is equals to 1 2 3 4 and B is equals to A B C and D. Now we will match the elements together like in this way. It means there is a 1 to 1 correspondence. 1 to 1 correspondence means if there is one element in the set A, there must be a corresponding element in the set B. It means that the number of elements must be equal in both the sets. It means A and B are equivalent sets. So we can say here A and B are equivalent sets. And the same thing is here, that A and B are equal sets. So the difference between them is, in equal sets we are concerned with the number of elements as well as the elements itself, while in equivalent sets we will only check the number of elements, either they are equal or not. So this is how they are different from each other. Now the last type of sets is types of sets based on, now the last type of sets is the type of sets based on membership. Types of sets based on membership. Based on membership. Now we'll see what are these types. First we will discuss them one by one, as we need a thorough discussion. These are very important types of sets that we have to use in almost every grade. So we discuss it properly, or you can say thoroughly. We will start from the subset. A very important concept that you must know, as you have to use it at various points in your upper grades, in 8th, 9th, 10th grade, and up to so on. Okay, we will start from the definition. How it is defined: if every element of set A is also a member of set B, also a member of set B, then A is called the subset of B. Then A is subset of B. So this is how it is stated. Now let's see its notation. with example. That is also very important. So it is basically written as, let's say you have two sets. A is equals to 1, 2, 3 and 4, and the set B is 1, 2, 3, 4 and 5. Okay, now we will see that is every element of A is in B. Let's do it by checking like this. Yes, 1 is here, yes. 2 is here, yes. 3 is here, yes. And 4 is also here. It means every element of A is in B. So here we get the concept of containment or inclusion. So it will be, how it will be represented here as, it will be represented by A is the subset of B. So this is called the subset symbol. A very important concept. So A is the subset of B. So keep this in mind whenever there are two sets, and in one set, if every element of set A is of one set is in the other, it means there comes the concept of inclusion or containment, or then we will represent in the form of subset as A is the subset of B. There is a few points related to subset that you have to keep in your mind, or we will write it here as empty set is a subset of every set, is a subset of every set. Okay, whenever you have given a set, then that set must have at least one subset. Then you can say, then you will think about it, what is that? Then keep this in mind, that empty set that we have discussed in the previously, that empty set and a set that have no element is a subset of every set. Okay, so this concept is very important to be marked. Another thing is, every set is a subset of itself also. Every set is a subset of itself also. How? Here we can say that the set A is a subset of A also. It means a set is a subset of itself. Is a subset of itself also. So these are the two concepts that you must keep in your mind, that every set is a subset of every set, empty set is a subset of every set, and set is a subset of itself also, like here that A is a subset of A. So this was the concept of subset. Now the second type of this set based on membership is superset. What is superset? Superset. Okay, we will start from its concept, its definition, how it is stated. If A is a subset of B, if A is a subset of B, then B is called the superset of A. Then B is called superset of A. Superset means that is having the all the elements. So B have A has, for example, 4 number of elements and B has 5 number of elements. Then we will say B is the superset of A. So what is its notation? Its notation is as, we can write as A is equals to 1, 2, 3, 4, and B is equals to 1, 2, 3, 4 and 5. First condition that you must check here is whether A is a subset of B. If A is the subset of B, yes, A is the subset of B here, then B is the superset of A. So this is the symbol of superset, right? So this is how we represent a superset and differentiate it from the subset. Okay, as A is the subset of B, that every element of A is in B, it means A is a subset of B. This condition is satisfied. Then you can say that B is a superset of A. Okay. Okay. The next type, based on the basis of containment, is the two parts of subset. Basically, subset was further divided here. How it is so? We have already discussed the concept of subset. Now we will see what are the further two types of subset. One is the proper subset and the other is improper subset. Okay, proper subset and improper subset. Now how they differ from each other? They differ from each other in a way that proper subset is stated as if A is a subset of A is a subset of but not equal to B, not equal to B, then A is proper subset of B, then A is proper subset of B. Okay, then A is proper subset of B and it is represented by, its notation is A is the proper subset of B. Okay, then we have improper subset. If A is the, we will write it as, if A is a subset of and equal to B, then A is improper subset of B. Subset of B. And how it is, and what is its notation? Its notation is A is the improper subset of B. Okay, so this is how they are basically represented. And you can say that if you have given the two sets and you want to check that, and if you are given the two sets and you want to check that they are proper or improper, then you can do it by taking the examples as you are having the definitions, by checking them one by one. Or you can say, if I take the example here, as for you I may take the example so that the concept can be clear for you. A is equals to 1, 2 and 3 and B is equals to 1, 2, 3 and 4. Now we will check if A is a subset of, here A is a subset of B, yes, A is a subset of B, but not equal to B. Yes, A is not equal to B because there are 3 elements in A and there are 4 elements in B. It means A is the proper subset of B here. So you can write as A is the proper subset of B here. So this was the example of proper subset. Now what is the example of improper subset? Let's have an example as A is equals to 1, 2 and B is equals to 1, 2. Now check, A is the subset of B. Yes, A is the subset of B. And equal to B. Yes, A is a subset of B. And A is also equal to B, it means that A is the improper subset of B. So these were the examples. So for your proper understanding that how they differ from each other. So I hope so that all these types of sets have cleared your concept how they differ from each other on the basis of different categories. So stay tuned for more lectures, and please subscribe to our channel for more videos related to these concepts. Thank you.